Hello, my name is Shramagan. Today, we are going to be building a circuit using an RGB LED, a potentiometer, and a photoresistor. RGB LED stands for red, green, blue, light-emitting diodes. These are all packed into one component. RGB LEDs give us a wide range of colors. Today's night lights on and off based on the amount of brightness in the room. They give us the option to see a variety of colors. I'm going to be using a SparkSpot Inventor's Kit. Parts needed. 1 RGB LED. The RGB LED is a 4-pin LED. Its pins are red, green, blue, and the common ground. Based on the combination of red, green, blue, it can create a variety of colors. 1 photoresistor. The photoresistor is a light-sensitive variable resistor. Its resistance changes based on the amount of light it receives. 1 potentiometer. A potentiometer is a 3-pin variable resistor. Based on its knob position, it outputs voltage. 330 ohm resistors. 330 ohm resistors are used to limit the amount of current that's passed through the circuit. 1 10K ohm resistor. The 10K ohm resistor is going to be used as a voltage divider. And 12 jumper wires. The jumper wires are used to connect the circuit together. Here is our RGB LED. As you can see, it has 4 legs. This one is the red leg, and here is our ground. The ground is the largest pin. This is our green, and this is our blue. Here is our photoresistor. As you can see, it has 2 terminals. These are 330 ohm resistors, and this is our 10K ohm resistor. Here are our 12 jumper wires, and this is a potentiometer. It has 3 pins, and the potentiometer has a knob. Pulse width modulation. We are pulse width modulating our RGB LED. PWM can control the brightness of each of the 3 small LEDs in our RGB LED, red, green, and blue. Pulse width modulation is pulsing power supply on and off at a certain frequency and pulse width. A frequency is how frequent the pulse is being sent. Pulse width is the percentage at which the pulse is on and off. Here is our duty cycle. A duty cycle represents the pulse width. In a 100% duty cycle, the current is on 100% of the time. So it makes a straight line and never goes down. A 50% duty cycle is 50% on of the time and 50% off of the time. In a 25% duty cycle, the current flows through 25% of the time, and 75% of the time, the current is not flowing. Safety. When working on a circuit, make sure the board is not connected to a power source, such as a USB power source or a battery power source. Now to the circuit diagram for our RGB LED night light. This is from the SparkSpot Inventor's Kit guide. Our RGB LED has 4 pins. Its blue pin is connected to A2. Its green pin is connected to A3. Its ground pin is connected to A4. And its red pin is connected to A5. The 330 ohm resistors are used to limit the current for each of the 3 colors. The first one is connected from E2 to F2. The second is connected from E3 to F3. The third resistor is connected from E5 to F5. The power pin of our potentiometer is connected to B15. Its output is connected to B16, and its ground is connected to B17. Our photoresistor is connected from B25 to A26, and our 10K ohm resistor is connected from B26 to C27. 5 volts from the breadboard is connected to the common power using this red jumper wire. This power flows through the whole column vertically. This red jumper wire is connected from the common power to E25. This gives the power to our photoresistor. The output of our voltage divider circuit is connected from E26 to A0 using this blue jumper wire. And the ground of our voltage divider circuit is connected from E27 to the common ground. This red jumper wire from the common power is connected to E15. This supplies the power for our potentiometer. The output of our potentiometer is connected from E16 to A1 using this blue jumper wire. The potentiometer's ground is connected to the common ground using this black jumper wire, which is connected from E17 to the common ground. On the red board, there are PWM pins, which are marked by a tilde. The pins are marked by a tilde are 3, 5, 6, 9, 10, and 11. So those are the PWM pins. Pin number 9 on the red board is connected to J4 on the breadboard using this red jumper wire. Pin number 10 is connected to J3 on the breadboard using this green jumper wire. Pin number 11 on the red board is connected to J2 on the breadboard using this blue jumper wire. These 3 jumper wires supply the power for the red, green, and blue pins on our RGB LED. The ground of our RGB LED is connected from E4 to the common ground using this black jumper wire. The black jumper wire connected to the common ground and on its other side is connected to the ground on the red board. This concludes the circuit diagram. Now let's start the code section of our circuit. This is the Arduino IDE. The sample code is from the Sparks from Inventors Kit website. To open our code, let's go to Files, Examples, SIK Guide Code Master, and let's go to 1D RGB Nightlight. So let's get started. Int photoresistor is equal to A0. So we're creating a variable called photoresistor and we're setting the value to A0. This will be used to store the values of our photoresistor. Int potentiometer is equal to A1. So we're creating another variable, and this time we're calling it potentiometer, and we're setting it to A1, and this will be used to hold the values of our potentiometer. And we're creating a variable called threshold, which is set to 700. This will be used to determine whether we're going to off our LED or on our LED. Int red pin is equal to 9, int green pin is equal to 10, and int blue pin is equal to 11. So on our red board, we have 9, 10, and 11 digital pins, and the 9 was connected to red pin, and the green pin was connected to the 10th, and the blue pin was connected to the 11th. And in void setup, which only happens once, we're going to do the serial begin 9600. So the serial begin activates the serial monitor. Serial begin starts the connection between our circuit and our serial monitor. Pin mode red pin is set to output, pin mode green pin is set to output, and pin mode blue pin is set to output. So the values of our green pin, our red pin, and our blue pin, we're all making them output pins. Now, in void loop, which happens forever, we're setting photoresistor is equal to analog read of A0. So we're setting the value of our photoresistor to analog read of A0. So analog read is a function that reads the value of any analog pin. So we connected our photoresistor to A0 and we're reading the value and we're keeping it in the photoresistor variable. And the same thing we're doing for a potentiometer, and we're putting the analog read of A1. Now Now serial.print photoresistor value, and then in serial monitor we're printing this string, and we're putting the value of our photoresistor variable in our serial monitor. And same thing we're doing for our potentiometer. We're setting the potentiometer value, and then in our serial monitor we're printing the potentiometer value. If photoresistor is less than threshold, so like if it's dark, this means that if it's dark, if our photoresistor is less than 700, then what we're doing is that if our potentiometer is greater than 0 and it is less than 150, then we're setting it to a function called red. So let's explore what these functions are. So void red is how we can declare a function. In this case, we're naming it to be red. And that we're putting the analog right of the red pin to be 100. So analog right is a function that sets values between 0 volts and 5 volts. And we're splitting that into 255 small values. 0 which being the lowest and turning off our LED, and 255 of which being the highest and making our LED glow super bright. So we're putting our red pin to 100, meaning that we're not putting it to its max of 255, but we're making the brightness level of red to be a bit low, and our green pin and our blue pin are not active because we passed them 0. Now in void orange, we're setting the analog right of red pin to be 100, and we're using our green pin to be 50, so our brightness level of the green pin is even less than our red pin. And this pattern keeps on continuing. Like for instance in void yellow, we set the red pin to 100, we set the green pin to 100, and we also put our blue pin to 0. In void green, which is the function green, we're setting analog right of red pin to 0. Our red pin is 0, our green pin is 100, and our blue pin is 0. In void cyan, we're setting our red pin to 0, and we're setting our green pin and our blue pin to both 100. In void blue, we're setting our red pin to 0, we're setting our green pin to 0, and we're setting our blue pin to 100. And in function magenta, we're saying that our red pin should be 100, and our blue pin should be 100, and our green pin should be 0. And in the turn off function, we're saying that all 3 pins should be 0 and they should not be active. So let's go back to our if loop. So in that, we're saying that if our potentiometer value is greater than 0 and our potentiometer value is less than 150, we're calling the function red, and we are making our RGB LED red. If our potentiometer is greater than 150 and our potentiometer is less than or equal to 300, we're calling the function orange, and we're making our RGB LED orange. If our potentiometer value is greater than 300 and less than 450, we are calling the function yellow and making our RGB LED yellow. if our potentiometer is greater than 450 and our potentiometer is less than or equal to 600, then we are calling the function green and turning our RGB LED green. If our potentiometer is greater than 600 and it is less than 750, we are making it cyan by calling the cyan function and making our RGB LED cyan. If our potentiometer is greater than 750 and it is less than 900, we are setting it to blue. And if our potentiometer value is just greater than 900, we are setting it to magenta. Or else, if it's just not dark enough and it is greater than 700, what we're doing is that we're using the turn off function and we are turning off our RGB LED. And then we're delaying it by every 100 milliseconds. And since this is in a loop, it happens forever, testing our potentiometer value and our photoresistor variable value. So this ends our code section. Now start assembling our project. Here is our breadboard and breadboard. They are attached to a base plate. Here is our breadboard and here is our breadboard. Here is our RGB LED. As you can see, it has 4 legs, the longest being our ground. Based on the combination of red, green, and blue, it can create a variety of colors. Here are our 330 ohm resistors. And here is our potentiometer. As you can see, it has 3 pins and it has a knob. Here is our photoresistor. As you can see, it has 2 terminals and it has a head. And this right here is our 10K ohm resistor. Now I'll start assembling. I'm first going to take this RGB LED and I'm going to insert it on pins A2, A3, A4, and A5. Now I'm going to attach this 330 ohm resistor. I'm just going to bend it. And I'm going to attach it from E2 to F2. Now I'm going to attach another resistor. And I'm going to attach it from E3 to F3. And I'm going to take this final 330 ohm resistor and I'm going to attach it to E5. Now I'm going to take this potentiometer and I'm going to attach it from pins B15 through B17. Now I'm going to take this photoresistor and I'm going to attach it from B25 to A26. And I'm going to take this 10K ohm resistor and I'm going to attach it from B26 to C27. These are our jumper wires that we are going to be using today. So I'm first going to be taking this red jumper wire and I'm going to attach it into the 5 volts. And from there, I'm going to attach it into the common power. And now I'm going to take another red jumper wire and I'm going to attach it into the common power. And on its other side, I'm going to attach it to E25. Now I'm going to take a blue jumper wire and I'm going to attach it from E26 to A0. And this blue jumper wire serves as the output for a voltage divider circuit. Now I'm going to take this black jumper wire and I'm going to connect it from E27 to the common ground. I'm going to take another red jumper wire and I'm going to connect it to E15. And its other side is going to be connected to the common power. I'm going to take another blue jumper wire and I'm going to attach it from E17 to A1. And now I'm going to take this black jumper wire and I'm going to attach it from E18 and I'm going to attach it to the common ground. Now I'm going to take this red jumper wire and I'm going to attach it to pin number 9. And then on the other side, I'm going to attach it to J5. Now I'm going to take this green jumper wire and I'm going to attach it from digital pin number 10. And I'm going to attach it to J3. And I'm going to take this blue jumper wire and I'm going to attach it from pin number 11 to J2. Now I'm going to take this black jumper wire and I'm going to attach it from C4 to the common ground. And I'm going to take this black jumper wire and I'm going to connect it from the common ground to the ground on the red. So this is the circuit that we have made and we have finished the assembly of our RGB LED night lights. We finished building our circuit and now it's time to upload code to it. So first I'm going to take this USB and I'm going to attach it one side to the breadboard and the other side I'm going to attach it to my computer. So now I'm going to share my screen and I'm going to open the Arduino IDE. So this is the Arduino IDE. Right here is an upload button in which we're going to use to upload the code. I'm going to click on it. As you can see, it is uploading. And it is finished uploading. So now I'm going to share my serial monitor, so we can see the values of our potentiometer and our photoresistor. So as you can see, like when the room is really bright, the photoresistor values are greater than 700. But when I keep my hand on top of the photoresistor, the values are less than 700. So currently, our values are close to 0 on our potentiometer. So as I turn it, the values change between 0 and 1023. The room is really bright and the value of our photoresistor is greater than 700. As per our code, our LED should not be glowing, and it is not. If I were to keep my hand over our photoresistor, it should be dark and the value should be less than 700, making our LED glow, which it is. Now let's explore some of the colors that our LED can provide us. I'm first going to set our potentiometer to 0. I'm going to keep my hand over our photoresistor so we can see the colors of our LED and to make it dark. When I keep my hand over the photoresistor, our LED is not glowing. This is because in our code, we said that we can only see colors when the value of the potentiometer is greater than 0. So if I adjust it a little above 0, our LED turns to the color red. If I continue, I get the color orange. And if I continue even more, I get yellow, green, cyan, blue, and magenta.